In this video, I want to introduce you to implicit differentiation. Now, to this point, most functions and equations that you've seen have been expressed in explicit form, meaning the function was written as f of x equaled, and then we had some expression in terms of x. Or you had an equation where y equaled, like x cubed minus 3x plus 2, again where y is expressed in terms of x. The important takeaway of explicit form is that one variable is isolated and its value is written completely in terms of another variable. On the other hand, an equation written in implicit form is one where one variable cannot be written in terms of another variable. For example, our x squared y minus 2xy squared equals x minus y. In other words, the x's and y's are kind of jumbled together in an equation, and it happens to be either difficult or impossible to write y in terms of x. So we'll need a new way to differentiate these kinds of equations, and this is called implicit differentiation. But before we get to our two examples, let's look at the equation y equals x cubed minus 3x plus 2. When we take the derivative of this equation, the y actually becomes either dy dx or y prime. And then we go ahead and we find the derivative of this expression in x as usual. So 3x squared minus 3. Okay, so this will be the same in implicit differentiation. Each time we differentiate a y term, we will treat the y variable as exactly like we do the x variables in finding the derivative. However, we'll need to include a dy dx or a y prime with the term. So let's go ahead and take a look at our first of two examples. So we're going to look at x squared y minus 2xy squared equals x minus y. We see that it's written in implicit form, and there's no real great way to solve for y or get y isolated and write it in terms of x. And we know this because we see a y term, but we also see a y squared term. All right, so when we do implicit differentiation, it's kind of a four-step approach. So the first step is going to be differentiating the equation term by term, and each time that we differentiate a y, we need to include a y prime with it. Okay, so let's go ahead and look at this first one, x squared y. Well, it looks like we have the product rule. We have x squared times y. So let's go ahead and use the product rule to find the derivative here. So it's the derivative of the first. So the derivative of x squared is 2x times the second plus the first times the derivative of the second. Well, the derivative of y is just 1, but since we differentiated a y, we need to include a y prime with it. So it's 1 y prime. Okay, minus, and now we'll need to use product rule again. So we have 2x, and that's being multiplied by y squared. So the derivative of the first is 2 times the second, and then we'll carry this minus through. And then we're going to multiply the first times the derivative of the second. And the derivative of y squared is 2y, but we differentiated a y, so I'll need to include a y prime with it. All right, so that equals now, and then this right side is much easier. The derivative of x is 1, and the derivative of y is 1, but we differentiated a y, so y prime. So our first step is to differentiate all these terms, and we're going to do so with respect to x. Okay, and we've done that. So kind of as far as our guidelines are concerned, the second step is to get all the terms that include a y prime on one side of the equation and all the terms that do not include a y prime on the other side of the equation. So first, let's go ahead and clean this up a little bit, and then we'll do that. So 2xy plus x squared y prime minus 2y squared minus, and this is all multiplication, so 4xy y prime equals 1 minus y prime. Okay, so let's go ahead and first indicate or identify all these terms that have a y prime with them. Okay, right there. So those are the terms that we need to get on one side of the equation by themselves, and then we need to kind of balance all those other terms on the opposite side. Typically, the y primes will always go on the left, and then we'll kind of kick everything else to the right. So let's go ahead and do that. So we have x squared y prime minus 4xy y prime, and then we'll have to bring this over, so we'll say plus y prime. As far as the other terms, we'll bounce them all to the other side. So the 1 is already there. So we'll subtract the 2xy and we'll add the 2y squared. Okay, so we've done that. All the terms that include a y prime are on the left. All the terms that do not include a y prime are on the right. So as far as our guidelines are concerned, step 3, we're going to factor out the y prime. Okay, so I have x squared minus 4xy plus 1. And that, of course, equals our right side. So finally then, in order to isolate this y prime, or solve for dy dx, we are going to divide both sides of the equation by those leftovers here after we factored out the y prime. So those cancel. Y prime is all by itself. And what we have here is 1 minus 2xy plus 2y squared all over x squared minus 4y plus 1. So here is going to be your first derivative. It's y prime has been isolated, so dy dx equals this expression. It's written in terms of x and y, and we did so using implicit differentiation with kind of our 4-step guidelines. In this second and final example, we're going to go ahead and use implicit differentiation again, and we're going to solve for dy dx, or y prime. So when I look at this equation, it looks like I have both the product rule and the quotient rule to contend with. So let's go ahead and we will differentiate term by term, differentiating everything with respect to x. So here we have the product rule, x times y. So it's the derivative of the first times the second, plus the first times the derivative of the second. Well, the derivative of the second, of course, is 1, but it was a y term, so it needs to be y prime. Okay, so now here's our quotient rule, which maybe you remember it as low d high minus high d low over low squared, or something of that nature. So when we do this, we'll end up with a fraction. So low times the derivative of the high minus high times the derivative of the low, and again, the derivative of y is y prime, all over y squared. And that's set equal to the derivative of a constant, which is 0. Okay, so we really need to clean this up a little bit. And I also notice with this fraction, after we use the quotient rule, that one of these terms does not have a y prime and one of them does. So I'm going to want to break this apart. Okay, so we have y plus xy prime plus, and this is y times 1, which is y, over y squared. So it'll simplify down to 1 over y, minus, and then we have x over y squared with that y prime, and that equals 0. So now which terms include a y prime? Well, this one and this one. So those are the terms that we'll need to isolate on one side, and we'll kind of kick everything else off to the other side. So we have xy prime minus x over y squared y prime equals, so we'll say minus y minus 1 over y. Okay? And then the next step then, now that we have all these terms in the places we want them, let's go ahead and factor that y prime out. So I'll have x minus x over y squared, and again it equals this right side, negative y minus 1 over y. And finally, let's go ahead and divide by those leftovers after we factored out that y prime. So x minus x over y squared. So those cancel. Y prime is all by itself now. And we have kind of a complex fraction here that's starting to emerge. So let's go ahead in the numerator and get common denominators. And then in the denominator, let's go ahead and get common denominators. So in the numerator, when I do that, I'll end up with negative y squared minus 1 over that y, all over, looks like x y squared minus x, all over y squared. And of course, when we have this complex fraction, we can play a little fraction acrobat and take this fraction and bounce him up and turn him over, because really when we're dividing fractions, we're multiplying by the reciprocal. Okay, that's what that will look like. And looks like the y can cancel with one of these y's. Also, I notice I have a lot of negatives here, so let's go ahead and do something. We're going to go ahead and factor a negative out of here, factor a negative out of here, and then cancel those negatives. So this will end up being plus, plus, minus, plus. And we can just switch all the signs like that. So when I multiply this y through here, I'll end up with y cubed plus y over, and then I have x minus xy squared, and that will equal my y prime, or my dy dx. So this expression here on the left side is going to be my derivative, and I found it using implicit differentiation.